Polarisation is a 3D phenomena, and as such it can be sometimes quite difficult to get your head round when we've got 2D notes. We're used to seeing a transverse wave looking like this, energy transfer in this direction, and our vibrations are perpendicular. This is quite a nice simplified form, but it's not actually the case what happens in normal life. If we imagine this is our direction of our transverse wave, what we actually have happening is not only vibrations vertical like that, there'll also be some vibrations maybe like this, some in this direction, and some horizontally like that. All of those vibrations are at 90 degrees to the energy transfer. So they all meet the criteria of a transverse wave. It's just while our wave is going along like this, we've got some going like this, some going up and down, and some going diagonally. So this is an unpolarised wave. What that basically means is we've got vibrations in multiple planes. All of those planes are perpendicular to the direction of energy transfer, and what that means is it can't happen to longitudinal waves. It's a really fundamental thing for polarisation, is it only occurs in transverse waves. So how do we use it? Well, if we imagine we've got two transverse waves, all of them unpolarised, so we've got your vibrations as such. What we can do is we can put some polarisers in front of them. For light, our polariser will be a Polaroid filter. So this one I'm going to call horizontal polariser, horizontal Polaroid, and the bottom one will be a vertical Polaroid. So what happens as our light comes in, it will only allow one single direction of vibration through the Polaroid. So a horizontal one will only allow those horizontal through, vertical one will only allow those vertical ones through. So this is now polarised light. So we've got something that's horizontally polarised, something that's vertically polarised. So this becomes really useful if we don't want a situation when we've got all these different directions, we just want one single direction of vibration through. If we combine our Polaroids, we can get, we'll put a horizontal one there, put a vertical one in front of it. As it goes through our vertical one, so beforehand we had all directions, afterwards we will just get our vertical one, and at the end there will be no light transmitted. So this is really important if we just want specific light to reach specific places or specific EM waves. This is an example of things they use in 3D cinema. So in your glasses, one of them will be vertically polarised, one of them will be horizontally polarised. So one single signal from the screen, some of it will be transmitted to your left eye, some will go through to your right eye, so you can see that different image which they can build to be 3D. It's also what they have in TV aerials. Different transmitters will send out different polarisations, and if you have a look, some receivers will be set up to the horizontal, some will be set up to the vertical, so in different areas you can receive TV signals. They also make sure they don't interfere with each other, so they send out different polarisations.